Hello everyone. Welcome to my video. In today's video, I'm going to show you the latest features I added to the etracer PC control software version 2.07 alpha. Okay. So I already uploaded this version to the website yesterday, and the major feature I added to the software is sound enhancement for the positive scan on the grid. Okay, so the first feature I added is the ability to test the tube under a positive grid bias. So let me show you how this feature works. So today we are going to test a 6L6 vacuum tube, which is the sibling or equivalent to a 807 transmitting tube. So I've downloaded the configuration file. So let's take a look at the configuration file. So because we are going to test this tube under triad connection, and usually for a triad connection for pentode, we connect screen to HB2 and plate to HB1. But here we have to connect both plate and screen to HB1 and use HB2 to control the grid. So the connection is a little different. Okay, and in the earlier version, it's not possible to scan to set the HB2 as a sweep source under quick scan tab. Okay, but now it's possible, so we can enable sweep, and for this case, we don't need to turn on the negative voltage output. As you can see, we are going to scan use HB2, and the output will be 10 volt, and the swing will be 10%. So the HB2 will scan at 9 volt, 10 volt, and 11 volt. Okay, the heater is pretty much heat up, so we can hit run. And here we get the result, the curve for this quiescent point configuration. The quiescent point is 150 volt on the plate, 150 volt centered at 150 volt, and we have 3 curves. This one is a grid voltage of 11 volt. This guy is 10 volt, and this guy is 9 volt. And we have the reading here, the current, the internal resistance, the mutual conductance, and the amplification field factor. And this line need to be changed. I didn't do that because this is copied from the data sheet for a negative grid, a negative biased 6L6. Anyway, so this is the feature for a quick scan to scan under positive grid bias. The second feature I did is enhancement to the full scan. So in the previous in the earlier versions of software, we can only scan either positive. We can only scan a tube either under positive grid bias or negative grid bias. So we have to do a post-processing to combine both to create a curve set, a complete curve set. And now it's possible to scan both positive bias and scan a tube under a positive bias and negative bias, and the output will be merged into one plot automatically. So to do that, we select the full scan tab. Okay, so you'll notice that this is a configuration file I generated to support this function. Previously, if you select only one sweep source is can be selected. So either we use HV2 or we use negative neg V. We cannot select both. But this new this software version can you can select both. When both are selected, you're actually telling the software you are going to scan both both under positive grid bias and negative grid bias. In that case, the software will ask you to scan for the first for the positive bias first, then followed by a negative scan. Okay, the file name is heat up pretty much. So let's have a look at this configuration file as well. So the connection is the same because we are going to scan. We are going to use HV2 for the grid control for positive scan. So we cannot use we have to connect the screen to the HV1, the same as the plate. The side effect of this is actually not big because screen and plate now share the current capability of HV1, which is limited at 300 milliamp. Okay, so let's click run. Okay, by the way, we need to check the configuration file here. So for the positive scan, we start from 5. We cannot start anything lower than 5 because when the device discharge, you only charge to a voltage of 3 or 4. I don't remember. So we have to start from 5, and we don't need to start from 0 actually, because for the negative scan we start from 0. So we start from 5 and all the way to 20 volts, and at the step of 5 volt. For the negative part, we start from 0 and to all the way to minus 50 volt at the step of minus 5 volt. Okay, so when we click the run, we'll see a message box pop up says both HV2 sweep and negative sweep are enabled. So system will perform 2 scans starting from with HV2 as a sweep source. So this line is important. We need to connect HV2 as a sweep source. So that means we need to connect the grid to the HV2 output and press OK. Okay, so the configuration of like this is suggested by Elk Moglia from Bartola Valves. So thanks to him for the input. Okay, so now we can see the curves from the at the positive bias. I also fixed the method to generate the grid control voltage. So as you can see, the scan speed is slower compared to negative scan, and the discharge takes longer because the discharge path is connected to a much higher resistor. But the accuracy is greatly improved. So if you remember the video I made like a couple months ago, the spacing between the curves in the positive bias range is not very even, or it's sometimes you can see a big gap, and that's because the grid current will affect the accuracy of the control voltage. And in this revision, I fixed that problem by taking the measurement twice. So the effect of the current on the HV2 output is compensated. So now you can see the curves are spaced nice and even. Okay, so after this, we'll have another message box pop up says please connect negative V as a sweep source. So it asks us to connect the negative voltage output to the grid. So do that. and we can see at the output the current status of the voltages, and we can see the curve start to appear for the negative bias. By the way, I also fixed a problem for quick scan that only affect the version 2.x. Under quick scan, because I changed the data structure internally, so for quick scan for pentode, if I only for the quick scan result, I only measure the I only use the current on HV1, even the source, the axis, the y-axis on the left side says HV1I plus HV2I. So in other words, I didn't take the current on the screen into account. So the measured current will be lower than the expected value. So it's fixed in this revision. So okay, the scheme is done, and now we have a complete curve from a positive to grid voltage to negative grid voltage. We can then save it and for future analysis. Okay, so that's pretty much about it. I hope you like this new feature. I'll see you soon. Bye bye.